Let's learn how to graph an absolute value function. If you look at my screen, you get a little hint of what they're going to look like. So the parent function is y equals the absolute value of x. So remember, your parent function is your most basic function. So let's make an xy table to get a sense of what it looks like. All right, so I'm going to pick some values for x. I'm going to go, I don't know, -4, -3, -2, -1, 0, 1, 2, 3, 4. It's always a good idea, to get some negative values and some positive values so you get a sense of what's going on. So if I plug in -4, the absolute value of -4 is 4. The absolute value of -3, 3, 2, 1. The absolute value of 0 is 0. What about the absolute value of 1? Well, you should know absolute value is always positive, so it's also going to be 1, 2, 3, 4. All right, one of the easiest XY tables you'll make. Let's graph these. So -4, 4, -3, 3, -2, 2, -1, 1, and then I've got 1, 1, 2, 2, 3, 3, and 4, 4. And look what I have created. It is a V. Okay, so it's symmetrical. It's got this line of symmetry, which is your y-axis. It comes to a sharp point. Remember, parabolas didn't? Absolute value functions do. Right? So I always remembered that when I was a student as absolute value. It looks like a V. Okay, so we're going to look at some different items that control the absolute value function and how it will change. So in general, more complicated absolute value functions look like this. This is your standard form. So let's talk about what these two things are. It looks a lot like standard form, or I should say vertex form of a quadratic. So the vertex here is HK, just like it was with quadratics. And I always said to you, opposite, same. It's opposite of the value you see in the absolute value because it has a minus sign in front of the H. And the K value is the same. Now, this A out front is actually the slope, but because it forms a V, it's the slope of the right ray. Okay, so if you think of it as two rays that meet at the vertex, this will give you the slope of the right one, and then you just use symmetry to get the slope of the left one. So let's examine these four functions and see if we can identify the vertex for each of them. All right, so let's start there. The vertex is this value and this value, but as I said to you before, it's always opposite, same. So opposite would be -3, same would be -9. Again, opposite, and then same. Well, opposite is +7. Same as what? There's nothing there, so it's 0. Next one, opposite would be -2, +8. And the next one, you see if you can answer. -4, opposite, same, -7. And I wrote one more that I didn't have as an example. What about this one for opposite, same? Since there's nothing inside the absolute value symbols, it would be 0, 3 for your vertex. Now, the slope of the right ray is just the A value. So take the coefficient in front of the absolute value for each of these. The first one would be -1, 2, 1/3, -5. Okay, I'm just taking the value out front. And the final one that I just made up there at the end would be 2. So if it has a positive slope, your ray is going to be going up. Okay? And then your entire V would be up. Whereas if the if the slope is negative, your ray would be going down on the right, so your V is going to open upside down. So let's put this idea into practice here and show you how you fit these pieces together. So my vertex, opposite same, is -2, -1. So I'm going to go and graph that. It's right here. And the slope of my right ray is 1/3. So rise over run. This is going to go up 1, right 3, up 1, right 3, up 1, right 3. So here is the right ray. The left ray is just going to be go the opposite direction. So it's going to go up 1, left 3. Up 1, left 3 for symmetry. Okay. So that's a very wide V. So the second question here is, compared to the parent function, is it wider or narrower? I just sketched the parent function, y equals the absolute value of x in here. The vertex is 0, 0, and the slope of the right ray is 1, so it goes up 1, right 1. So if you were to compare the width of that V, the blue one is definitely wider. Okay, so notice when it's 1/3, it's a fraction there, smaller than 1, it gets wider. Let's do another practice one here. So our vertex, let's start by identifying that. Opposite same would be 3, positive 3, positive 2. Opposite same. So I'm going to go right 3, up 2. And the slope of my right ray is negative 4. I'm going to make that be a fraction, negative 4 over 1. So I'm going to go down 4, right 1. Right here. And I'm going to do it again, down 4, right 1. And I'm going to sketch my right ray. My left ray would be down 4, but I'm going to go left 1. Down 4, left 1. Okay. And finally, the question is, how does it compare to the parent function? Is it wider or narrower? So again, I just sketched in the yellow parent function. Vertex is 0, 0 with a slope on the right ray of positive 1. How does that compare in the width? Well, this one's definitely narrower. So notice what's controlling that. That's your slope. So this time the slope is, or the absolute value of the slope, which is 4, is greater than 1. So when it's greater than 1, it's going to get narrower. Same idea, we talked about this back when we were graphing parabolas. Okay, so just some kind of theoretical questions here. It says, how do I change the parent function if I want to reflect it across the x-axis? Well, again, the parent function is y equals the absolute value of x, and this is a v with a slope of 1 on the right ray that is at the origin. So if I want to reflect it, that means I want it to open upside down, okay, on the x-axis. So what's going to cause that to happen? Well, my a value, if I just make it be negative, okay? So it would be y equals negative times the absolute value of x. It's going to have a slope of negative 1. The second one's asking me, what if I want to shift it down 5 units? So again, if I start with this parent function up here in purple, and I just want to move it down 5, if I shift it down 5, well, what's changing? The y value of the vertex. So this one's going to be, how do I change that y value? Well, I just drop it 5 units in the vertex. So the k value here is what changes. What if I want to shift it to the left 2 units? Well, let me do that in green. I'm getting quite a few on this. If I want to shift this to the left 2, okay, the value inside parentheses is going to change. So a mistake some kids would do is they would write this right here because they're thinking I want it to go to the left, so they make it the absolute value of x minus 2. But remember, it's opposite on the inside. So you would actually make this plus 2, and your vertex would be negative 2, 0, opposite same. And if you're hearing the nail gun in the background and you're curious what that is, that's just my husband installing trim upstairs. So that's what those noises are. All right, please reach out if you have any questions.